Well, happy Monday to you guys. Happy second day of grade 9 applied math. I'm happy you're here, and I'm sad that I can't be with you today. However, I'm with you in spirit and in voice here. And we're going to start today by reviewing the things that we did on the very first day together. So make sure you have a copy of the handout called Day 2 Warm-Up, which I have right in front of me. We're going to first review the Pythagorean theorem. And if you look in the classroom, above the teacher's desk, kind of in the corner there is some information about the Pythagorean theorem. First of all, I want to remind you that the Pythagorean theorem is used only with right-angled triangles. So make sure we fill in that first blank with right-angled. If you try using the Pythagorean theorem with something other than a right-angled triangle, you're going to get side lengths that aren't actually the correct side lengths. Now, also remember that the hypotenuse, which I often use the letter H for hypotenuse, it's the side across from the right angle. And hopefully you remember that that right angle is always marked on your diagram with the nice little triangle, sorry, not triangle, little square in the corner of your diagram. There we are. So in this first question down here, we know that the side across from that square in the corner is going to be the hypotenuse. So I'm actually going to label that as H for you here. H. All right, the hypotenuse is always the longest side of your triangle. So you can fill in the next blank with the word longest. All right, and if we are finding the length of the hypotenuse, like we are for letter A, for number 1A, you can use that formula that we had from the other day where we had, let me just change to the pen tool here, where we had h squared, the hypotenuse length squared, is equal to the a squared plus the b squared. And remember, the a and the b are your shorter sides of your triangle. They're called the legs of the triangle. If you happen to be finding the short side of the right triangle, you can either rearrange this formula that we've just written down, or you could use the formula of a squared equals h squared, the hypotenuse squared, take away the short side squared. Okay, and whether I have an a equals, a squared equals, or a b squared equals, the a and the b could have those roles switched. So I'll just do it in a different color here. You could also say that b squared equals h squared minus a squared. It doesn't really matter where the a and the b go in terms of they can swap spots, but what's important is if you're using this format, you always have the hypotenuse squared first, and then you've got the take away the short side. So use those two versions to help you answer or find the length of the unknown sides for these two questions. So I'm going to continue on with the video. You guys can come back to this after we go through the review part and complete the sheet at your own pace. So let me scroll this up a little bit here, and let's talk about perimeter. Now, you should remember that the perimeter is that distance around the outside of your 2D figure. And to get that distance around the outside, all you need to do is add all the edges together. So while we had a formula sheet from the first day, really for perimeter, you don't need your formula sheet. You just have to remember to add up all the outside edges together, and only the outside edges. And then sometimes if you have a curved edge, like a half a circle or a quarter of a circle, then you will need your formula sheet maybe to help you with the circumference for the circle. So in that blank, you can put the word outside. So you're going to figure out the perimeter for each of these figures. The first one's just an irregular quadrilateral. Quadrilateral just means four-sided figure. And the second one is a triangle. So just make sure it's the outside edges only that you're adding together. All right, moving along here. On the back, we have area. And remember, the area is the amount of space inside the 2D figure. So when we're calculating that space inside the 2D figure, make sure you use the formula sheet to help you with the correct formula for determining area. And make reference to the different letters they're using and where those letters appear on the diagram. So we talked about, for example, the trapezoid that we have in 3B, what those letters represent. So try and relate back to that. And you're going to figure out the area for the two examples here in question 3. And then when you get to question 4, you're going to do both the area and perimeter for both of those figures. So make sure down here you're finding 2 things for each one of these diagrams. So area and perimeter. So take some time right now, complete that sheet to the best of your ability. Make sure you include units. It's nice and readable. Make sure your name goes on that, and then you're going to hand that one in, and I'm going to take a look at that to see where you guys are at this point.